have a background of working in Microsoft internal engineering teams, in earlier in Windows division and then Azure division and other teams as well in Microsoft. So here's what we are. So I'm going to talk about building modern apps today. So agenda here is like, why you have to modernize traditional apps. Then quick review of some key concepts. And then how to choose the right options. So I'm going to focus more on how we redesign some certain architectures from monolithic applications to modern applications. Because sometimes what I feel as in hey, as a person who's coming in and using cloud every day, there are zillions of services that's available in cloud today. And moreover, as a developer, and then I have to sometimes say, when do I need to choose what? That's always kind of the trouble thing. Anyone will go through, hey, I'm starting new with cloud, or hey, I've been using cloud for a long time, but even then, how do I know that this service is better than another service, right? So that's my focus here on today. Introducing you guys to multiple different services and cloud services in Azure, and also when to use what. So that's what we're going to go through. So, why modernize traditional applications? So you guys can ask me any questions anytime that you want, and I would like this session to be as interactive as possible. So, hey, anytime, please interrupt me. So, why don't we have to modernize traditional applications, right? Anyone want to jump in?
Take advantage of the cloud.
Sorry.
Take advantage of the Azure cloud.
Yeah, that's correct. Take advantage of cloud.
I think cost reduction.
Yes, cost reductions, yes.
What do you mean modernize?
Oh yeah, that's a good term, right? I'll come to that term later on, yes.
I mean, not every part of a monolithic application does the same kind of work. If you want certain parts of the application to do more work, you have to break it down into smart apps, and that's how modern applications work.
Yeah, give compute power to the places where it needs more compute power, and remove the power from the processing data.
Sometimes the operating system and the development environment, they do expire. Like some app developed 10 years ago, so it's due for
being current in versions. Yes. Then.
Being able to scale and make money.
Oh yeah, of course. Yeah, that's more important for any business, right? Yeah. Okay. Alright, yeah, you guys are all right. And then gentleman back there, he was asking the right question, what do you call by the term modernization, right? I would like to just dig into that one here. So if you see, modernization is not actually a new term. It's been out forever. It's been out there in the industry forever. If you see, software development as a business, as it started occurring from the era of mainframes. So moving from mainframes, let's say, to client-server application, that was modernization at that particular period of time. And now we are in cloud, so that is the modernization. It's relative, the term is very relative. So what stands today as a modern application may not be the same after 2 years. So you will have to keep modernizing. So it's not going to be like a switch, hey, I've modernized my application, and that is set and done, and that's it. No, that's not going to be the case. After 2 years, you're going to redo some of these things and then modernize the application into whatever the services that's available current in that present time frame, and then see how it's going to be useful for you. So modernization is never a new term. So does that answer your question? Alright, okay, let's move on. And then I just wanted to touch base on the history of application development. And in here, you always had legacy apps, or what we call as monolithic apps. And then we had the internet come in, and then we had we have service-oriented architectures, and then distributed computing come in, and all that. But now, today, we are in the cloud application era. So it's we're building, we are utilizing the compute power from cloud, so that we don't have a tangible physical systems and machines, and we're using this kind of compute power, and then we are making sure our application processing times are much better and much resilient architectures, and then introducing concepts like disaster recovery, and then monitoring, more securing applications, and then also making sure our time to deliver the application to production is also reduced. So there are multiple things that's happening here. And then just basing on hey, what are the application tiers here? So even if you take it from very old applications like monoliths, even to microservices today, this stays the same. This is going to be the canonical 3-tier application layers. You will have a front-end layer, and you will have a middle-tier layer, and you will have a back-end layer. But then how these are segregated is what differs from monolithic application to more microservices application. In a microservice, you do not segregate front-end separately, middle tier, and then the database tier very much or too much separately. Would rather you would have a virtual link together, and then so let's say you call microservice as the unit feature of an application. Let's say there is a feature A, and then the feature A will have its own front end. It will have its own the middle tier component. It will have the database component. In case of monolithic application, all the features will have one service called the front end. All of them, all the features will have the middle tier component. All the features will share the database component. So that's where it differs, but technically all of the applications will have these 2-tier components. So then evolution of hosting platforms. So the interesting piece is hey, how many guys are working with containers? Okay, how many people are aware of containers? Oh, that we have a lot. That seems to be the buzz term nowadays, right? Technically not. Containers are there. Containers have been there for a longer time in the industry. And then now, this is just to say, hey, what are all the things, the newer things, possibilities that's available today? We have on-premises, infrastructure, and then we have in cloud, we have infrastructure as a platform or infrastructure as a service. That's one of the one type of a cloud service. Another one is container as a service, another type of a cloud service. For example, we have Docker containers, we have Kubernetes, AKS, for example. And then we have a platform as a service. And then the next one is functions or serverless as a service. So this is where you're completely going away from the tangible or known infrastructures and then moving away to serverless methodologies. It's okay, I don't, as an application developer, I shouldn't be worried anymore about being current, and then about maintaining the server. Even in cloud, people have to still maintain your compute power, maintain your service and stuff. So as a developer, how can I move away from even thinking about my servers and then move more into okay, how do I deliver my application? What's the quality of my application? How do I test my application? And then how does it actually behave in a customer environment and all that, right? So that's where your thought process will move. Any questions? Yes.
Will you be sharing the PPT or?
Yes. Yeah.
So we can stop taking pictures, right?
Oh yeah, sure. Okay, all right. And then, so some of the ways to modernize an application, right? So just walking through the high-level design is let's say we have a traditional application, and then what we can do is just lift and shift. That means that, hey, I have an infrastructure, on-premise infrastructure. I have a so-and-so application running now, and then I just want to move my application to cloud. Basically saying, hey, I want to move to cloud, right? You just lift and then shift your application. That means that whatever was your, let's say, the same configuration of your on-prem infrastructure, it's going to be the same. It's just a repetition of it. But then you are in cloud. So instead of you maintaining and managing your own data center and the server in the data center, you will be essentially moving your data center to cloud, and then you will be now managing your particular data center in cloud. So this is where it will be just lift and shift. That's the knowledge. So, and then your lift and shift of application can be hosted in any of your VMs or your containers. So that's the infrastructure as a service or the container as a service. That's the platform that you will be moving to. Then the next is what do you mean? And then the next term is modernization, right? Because you literally moved your application X to another place, just the same thing. So you didn't do a lot of things. You just had to change the configuration pieces, host the same thing in cloud. So that was the feature. The next piece is modernization, because you're going to do something else than what your application was today. So you're going to change a couple of things. And this is where you're going to break or you're going to decompose your application. So that's where you're going to make it into multiple microservices, right? So that's the next, that's the modernization. And then once you decompose your application and then you transform them and then you try to play around with them and then say that, like, hey, this is kind of like, and now that I try to break my application into a microservice, but I feel like, you know, moving things around and then having this particular design makes sense anymore. Like, you know, earlier it would didn't make sense. Now that I moved, or now I broken this piece into a microservice, now you have the freedom to move things around and actually, like, you know, do more of like effective, let's say, like, hey, this is what I believe this microservice does now, and then this wasn't happening earlier. I can actually break those changes. This will not become any more breaking changes. So that is the flexibility that you get by decomposing the application. And once you decompose, and then everything gets transformed. So it's basically the same application to a business user or customer. It shouldn't be any more different, but the way that the application is structured is a little different. So that's all it is. Any questions? All right. So, but the beauty of moving to cloud is, like, you can stop in any layer you want. You need to always go to the end to decompose and then, like, you know, modernize. Because certain applications, certain business critical applications will be like, hey, I just need to go lift and shift. You needn't try always to modernize those applications. It's like, hey, that works that way because of certain, like, you know, process, and it's like, hey, I don't want to do this one. It's okay, you can stop it right there. And then you can say that, like, hey, no, this application I need to move it as a microservice, but I don't want to do any more breaking changes. Okay, yeah, you can stop there. And then some applications you can just go around and then you make breaking changes. Yes, please. Do you have a question?
Yeah. So are there any exceptions right now that this particular service or this particular application can't be containerized? I see certain articles related to databases where they say that it's still beneficial to have instances running on a VM rather than a container when it comes to databases.
See, again, like mentioned, it's case by case. I cannot be generically saying that no, it doesn't work that way, no, everything has to be left and shift, or everything has to be modernized, or any database cases are going to be like that. So it's case by case. So you're gonna read through or, like, you know, what works for your particular scenario, and then you use it like that. So is there anything specific that you wanted to ask about?
Like a general idea, like, okay, the resource for this particular part of the application shouldn't be containerized, and only APIs, or that's more beneficial to be containerized.
Yeah, it's like, you know, it's more generic. The topic is, like, you know, it has to be case by case on specificities, like, you know, when you need to modernize that.
So I find challenging this step number 3 to decompose a legacy application into microservices. Yeah.
Yes.
So are there any guidelines for type of application or you know, some use cases that Microsoft provides? Experience of different customers, because if the legacy application is very big, yeah, then you have to have the application running. You need to do like kind of a hot swap. Yeah, you have the application running, but then you slowly change it to microservices.
Yes.
But keep the application still running.
Yeah, never do a hot swap, by the way, especially with legacy applications. That's from my experience, I would say that. It's like you always take it slowly, have like a hybrid move, rather than like one day I just wake up, I know I want to make it as a microservice. No, that's not going to work out. But then I need to check on what kind of updated documentation available for what you asked, and I can connect it with you.
I meant hot swapping in each iteration step, you know.
Oh, yeah.
I guess you can change the core of the application, microservice. You do a hot swap, see how it behaves, and then I guess
then you need to worry about like backward compatibility within your like downstream systems. Upstreams are still okay, but downstreams are still talking to your application. When it comes to legacy application, that will be a lot, and you need to be very careful about how do you want to move your downstream systems from the monolithic application to microservices. How that move is going to be like, so it's a lot more of let's say orchestration to deliver that kind of project. rather than it's not just technology anymore. It's coming to organizational practices. What is your change management looking like? And then what's my orchestration? Who's my orchestrator is going to be? Somebody has to oversee all these kind of events, right? So it's not going to be a simple activity there. But let me just see if there is any specific guidance that's available. Yes, please.
Is it significant difference between calling piece of code inside a container
Yeah.
and jumping between containers? If I put these two pieces of code in different containers, what is the difference? Is it significant amount or just is
It depends on the code.
it decomposing too much?
Yeah.
Probably means the same as in database. If you decompose too many information, if you have too many tables, after some level, it's not useful.
It's not the yes.
Because you will have too many keys, etc., indexes, it will not help you anymore.
Yeah, no, definitely. That's
The
it.
same here. If I code inside in the same container, it's not easy. Just.
So yeah, when you
If I
sorry.
put different container,
Yeah.
it needs probably time. But if I put million times this container,
Yeah.
it's probably significant.
Of course, yes. So the question is when you're decomposing, do you need to always decompose into too many microservices? What is the best practices there, right? So there are multiple ways to decompose to a microservice. Example, certain microservices can be called as vertical components and will just serve only your application. And then there could be microservices that are horizontal and could be serving multiple other applications in your enterprise. So this way, every application or every application team or project team need to build their own microservices. So they can actually utilize, share the horizontal microservices that's available in your application or within your organization in the in the company. So that's one thing. So another thing, best practices is when moving into microservices, we will be doing a work. Hey, DevOps is also there. That means that people are going to collaborate together and build more things. In that case, you will be building something called a shared libraries. So it's more recommended to go towards a shared library approach and then collaborate code within the company and then have build horizontal microservices that rather serves the whole company as serves the whole organization, not just one application anymore. So so this way you will have a balance of what you build specifically for your application, and also you do not build too many microservices, and you keep a balance of hey, I can share things across. Yes.
So meaning you should perfectly know your business area.
Yes.
How it's exactly.
Yeah, I'm going to walk you through a sample example of how you can break a scenario and what you call as horizontal, what you call as vertical.
Thank you.
Okay. Any other questions? Okay. Let's move on. So some of the emerging application patterns, right? Just introducing, hey, earlier I spoke about serverless. That's one thing. And then next is artificial intelligence. That's like the couple one, no? And then you have Microsoft Graph and also making sure that your application is supported across multiple devices. So that's another thing that's going to come. Hey, you have Android devices, you have iOS devices, and then have my Chromebooks, I have my Surface laptops, and then multiple other devices that you have. Your tablets as well. How do you make sure your application is displayed or working across all those devices platform, right? So that's a very important aspect too. So have you guys heard of Microsoft Graph? Sorry.
Oh, yes.
Oh, okay. Or do you know what is Microsoft Graph too?
Principle.
Principle, okay. Yeah, so Microsoft Graph is basically your developer platform for identity and Office 365 and all that. So example, hey, I have my application, but then I want to provide a unified experience to my customer. That means that most of you would have seen hey, if you go into some websites you will ask you to sign up using Facebook, right? Sign up using Google, sign up using Microsoft ID. So these kind of signups, that means that you're not creating your own signups, which you will have to manage, and you have to remember passwords and so many things. You are providing a unified experience or a good experience to the user, like, hey, I already have some authentication with some of the other applications, so why don't I use the same thing somewhere else? So Microsoft Graph kind of helps you with that. So that's one thing. That's your Azure Active. That's linked up to your Azure Active Directory platform. In case of enterprises, there's something called an internal Azure Active Directory. Like all your enterprise employees can just sign in, and then you will have your single sign-on experience. In case of customer side experiences, we have like your B2C services available, where you can map for like, hey, I can bring in my Hotmail account, I can bring in my Google account, I can bring my Facebook account, and still sign in with those accounts. So those are the differences. Then digging a bit into Microsoft AI. So in AI platform, you have like multiple different services in Microsoft AI platform. Spot framework, cognitive services, machine learning, APIs, you have machine learning studio, labs, and everything. And then what they serve is like, you can use these services for customer care applications, sales and marketing, and then any kind of workplace analytics or any custom build bot or any kind of custom build. So I'm just going to take you through a scenario and then say like, how can we modernize that particular scenario or workflow? So this is what. So this scenario is just custom calls. Every application today or every organization has some form of custom calls, right, or custom support. So I just want to walk through this one. So let's take an example where a customer calls support. The user tries to load page of XYZ app, and then user retries a couple of times, and then tries to contact the customer services now because like, hey, the user was not able to load the page. And then the user waits for the issue to be resolved and notified. So it's a long process. How many times did that has happened to you guys? Or similar, yeah, or your customers. Okay. So
it's a lot.
Okay. Yeah. So, and that's not bad. It's like, yeah, sometimes we have a bad day and the application goes down. It's okay. But it's about like how you handle the scenario, right? How ourselves like are providing, how we take like customer support or customer experience as first, and then how can we provide the best customer support to the user, right? So let's list down the problems, right? Like hey, what are the problems here in this scenario? The cost per customer support call is higher since it takes longer time to resolve the issue. That means that, hey, the customer is calling someone and then somebody is trying to resolve it, and then that person is going to contact the application team internally, raise a bug, hey, this is happening, can you please identify the problem, like, hey, what, then they have to provide a fix, and once the fix is there, the fix has to be deployed, that has to go through change management process, blah, 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 and so on. So this is what happens in any organization, right? And then this problem, this page load error, was never predicted earlier. So this is more of a reactive approach, like when someone calls you and tells you, like, hey, something's wrong there. Then rather it would be like, if my application was intelligent enough to just like kind of predict, like, hey, a lot of traffic is coming to my application, can you just like stop it there? And so that wasn't done. So there was no resolution, more in a predictive thing. That's one thing. And then the approach is more reactive, that's bad. So the agility to solve the problem is very low. And then also customer satisfaction is low. So what do we do to improve the customer satisfaction here? So yeah, like, why guesses?
Put a chatbot in front.
Okay, right, yeah. Yeah.
Fix the system. Probably we should design this approach like it should start from checking with computer.
Sorry?
Checking with computer.
Okay.
Using AI bot or something else.
Yeah, okay.
If AI bot is not able to help,
Yeah.
it should automatically,
Yeah.
not like suggest call this or send email, automatically inform or notify real person.
Yeah, but we're talking about the
At
page
same
itself
time,
not loading, right?
Not like I received a suggestion to send my complaint by email, and I will wait days
Yeah.
for response.
Yeah. So yeah, chatbot
But
is.
it should have definitely, it should allow me definitely immediately contact a real person.
Yeah.
Because I have bad experience buying airplane tickets
Yeah.
when definitely computer was not able to resolve my issue. And I tried different scenarios just to get a real customer support. I should be, have to be really inventive
All right. Okay.
to
So
call
yeah.
customer support.
Yeah.
Maybe there are two different approaches to this. First approach being like the page is not loading, maybe the server is down or something like that on the server side. So maybe you have a approach where automatically one particular server is down automatically, or your environment ups and another instance of the same server. That
Exactly.
kind of an
Like a
approach.
load balancer.
Or
Yes.
yeah.
An intelligent load balancer.
A second kind of an scenario could be you have a latest release that's going into production and something has gone wrong with that particular version.
Yes.
So you have an approach where, okay, it's this down, this is client-facing website, thousands of users are using it. Just roll up and roll back to the previous version, and everything is up and running. And then you take your time to basically see what's wrong with that particular version. So
Yeah. What you said is right. That's
Actually,
modernization, but it's
not-
also reactive.
Probably it's
Right?
not doable because you don't know how it will influence other customers. You can resolve this issue, but receive many other issues with previous version.
Okay. Yeah. Please go ahead.
Yeah, so I'm not from a technical side, I'm more from a business side. How I see this is kind of adapting proactive approach, understanding some scenarios and providing
Yes.
a guide or path for it so that when the customer sees that error, they should do the first step at least, or second step, like a flow, what they need to do. Or
Exactly.
maybe you can provide some documentation, videos already,
Yeah.
so that they can go and try to resolve their problems on their own first, and then come to, call somebody and do that.
Of course, yeah. So we're going to talk about the combination of what you mentioned and what you mentioned on yourself as well. So all of you guys. So we have to take to this approach with more predictive approach plus reactive approach. We have to have the balance so that we give the best experience to customers. I'm going to walk you through the experience. So the multiple users are affected with a higher page load time. So this is even before the page actually goes down. Okay, when even the page load time is actually increased. So you can have your prediction algorithms running within your application saying that, hey, this is an anomaly because my load times are more than usual. Okay, then how do we see that? Okay, yeah. So there is something going on. We do not know if that's only a traffic problem or if it's a genuinely an application problem or hey, curfew problem from an application. So that's the one thing. So application can identify this anomaly. All that you need to do is have your telemetry data. You need to get that one in, and then you will have to have a background service that continuously verifies the telemetry data. This means that you need to have a base number. So you will have your performance when your load test done, and then you will have a base number, and that base number you will take it up. And from that base number, you always verify, hey, is there an anomaly? On a continuous and periodic interval, you will be verifying that. So that's one thing. And then all the user app specific page load times are logged into the telemetry platform. That means like, hey, this is my base time, and these are the times anomalies I'm verifying, and then you will be seeing respective other monitoring data that goes along the system. And then what happens is like this particular system, the intelligent system that you have built into the application, it can actually see what is the particular anomaly, and it would also create a bug and assign to the particular team and saying that like, hey, there is an anomaly here. Just go and verify if it's a problem within the application or it's just a traffic problem. You see, right? You need to have a human intervention there. It's not like all the bots can do everything, so you need a human intervention there. So the bot is just going to just create that particular bug or a ticket to a particular application. So that's the first step. Then once that's done, the application team can identify the bug. They say, hey, no, this is just like a pure traffic situation problem. I just need to auto-scale the application. Or after that, you would modify how you will auto-scale the application. So that's it. You can auto-scale the application on particular days, on particular schedules, or something like, you can then say like, hey, number of users increases in this time, then auto-scale the application, right? So there are multiple ways to define auto-scale. So you redefine auto-scale. So that's one way to do it. Or otherwise, like, hey, no, this is genuinely my application problem. there was a new release last weekend, and that kind of screwed up my page load times. Now I'm going them back and fixing that particular performance of that small change that went in last week. You see, right? So that the application team defines, and then they identify and also deploy a fix. And once that fix is done, this ticket is already available. This new fix, whatever was done, it's already available even to the customer support. Even someone calls like after this, so this is like you already predicted the problem and you are solved the problem. But while solving the problem, if some customer calls, this information is available to the customer support to then tell customers like, hey, someone's actually solving this problem. Hey, you will solve it in like a few days or a few hours or something like that. So this is keeping your customers informed from the business perspective. And then next is this relevant anomaly is also fed. This data is again fed back to your engine, which kind of predicts again, right? So this is like you continuously improving your prediction algorithms as well. So that's the next step. So all these things are your prediction steps. Then next, going forward, then you will have the reactive steps. So this is where you implement a chatbot. So just make sure, like, hey, customer always have this kind of support. And then the chatbot as a bot identifies like what customer needs and then answers the questions. Otherwise, reacts to a agent. And then all this, as from the business who's actually running the application, all this data, this report are all available in dashboards. So that's one thing. So this is a way to actually deliver this kind of scenario. So in here, what you have done is actually modernizing a piece or scenario of the application. It's not a complete application by itself. It's just one piece that you have modernized. So yeah, this is the way. This is one of the ways I would say to modernize an application. Any questions? Yes, please.
Does Azure have any service to do all this load testing and tell us the report actually like, okay, in this scenario the load times were this much, when the users are this much, the network is down, like, do you all have any service?
So, you do not have a particular scenario, that's the telemetry data, that's like, you have two services in Azure, that's called Azure Apple Size, and then you have Azure Log Analytics, so those are the two services that you have. And then the next is like for your load testing, there is a specific load testing service actually. It's part of Azure DevOps currently. You can load test your application for performance and load test. Yes.
What was the first one?
The first one, application insights, and then log analytics for monitoring, and then for load testing in Azure, as a part of Azure DevOps, you have load testing for your application. And if you have Visual Studio as an ID, then you can also load test from your Visual Studio directly. That's also another possibility. Yes, please.
Actually, you can experience application insights on development stage.
Sorry?
You can experience application insights on development stage.
Yes.
And tools options allow you to turn it on, off, whatever.
Oh, yeah. So,
for example, in Azure, if you don't need it, but it's assigned automatically to your job, Azure job.
yeah. So that could be.
You need to cancel it because you will pay money for nothing. It's not useful.
No. Yeah, I understand. Okay. So I will just complete this one and then we'll take a quick break. So what are we essentially doing in this scenario? It's nothing but providing an app platform experience. And this can be divided as three different experiences. One is user experience, that's the first foremost important. Second is your business performance, and then next is business operations. So this is to make sure you are providing a seamless product or service experience to all of the customers. That's one thing. That's what we did. And then in the scenario, right? And then the second one is like increase your business performance by leveraging data-driven decisions, right? That is making sure that you are getting all the monitoring and the telemetry data, and through the data you are making a lot of decisions. Your application team is taking decisions, your project managers, and then your business leaders are going to make decisions. So that's one thing. Second, and the last one is business operations, right? How do you make sure you run the applications with highest possible performance? So that is the business operations. So what we deliver essentially in that scenario, all those steps, the 9 steps, will cater to all these 3 major problems. That's what it is. All right, yes?
Does these 3 platform experience line up with the tier that you showed up earlier? you showed up a tier where it's the front end, and then the third is the back end. It seems like it's lining up these three together.
Actually, all these three will not do all of them.
Across.
Across.
Okay.
So if you put it then in a bucket, then you will not get the experience.
Okay.
So because if let's say in order to provide user experience, you need to get a good front end experience. But in order for the front end to run, you need to have a good computer power, and that means like your middle layer, and then in order to provide all the retrospective data, you need the data layer. So if you just for user experience, I'm going to use all three layers.
Gotcha.
So it's always all three examples.
Okay.
Yeah. Okay. So yes, please. Let's take a quick break, but I'll ask quick questions. So people can take a quick break.
So in general, Modernize NET means moving to the cloud, right?
Yes.
I think the biggest question is, I think somebody asked that previous session that nobody answered it. Is this security honestly? Specifically, if you're working in the financial industry,
Yes.
like what do you do, like in general, to convince your clients to move their data into the cloud?
That by itself is a so you have a lot of security concerns in terms of financial services. There is a lot of documentation already available. Let's say in Azure, you can go check that information on security, data privacy, and all that information. There are specific application architectures where you can adopt to make sure you have the highest possible security measures there, highest possible data privacy.
Is there anything like guaranteed by Microsoft or by their?
Sorry?
Is there anything guaranteed by Microsoft or like their Azure platform that your data will not ever be leaked or hacked?
Yes, there are. So depending upon the services you choose, depending upon the SKUs that you choose, then you will see like SLA timeframes, and so it all comes to what kind of architecture you're going to implement using the Microsoft services, right?
Yeah.
Like an example in Azure, let's say you're going to use the infrastructure as a service.
Yeah.
That means that Microsoft is providing you as a platform, but on top of it, you are going to make sure like you are implementing all the security.
No, okay.
You see, right?
Yeah.
So then next is like, okay, I'm going to use containers. So say, yeah, containers give you somewhat, and then after that, you are still responsible for making sure you implement your own security pattern. So that's what I mean. And then you go into PaaS services. In PaaS services, it's like, it's like 80-20%, right? Like 80% is Microsoft provided, but 20% you need to go and configure for what your specific needs are. That's what it is.
Yeah.
So this is always going to be like 50-50 or like 75-25 or 80-20, and just the percentage of this is yes. There was a question in the back. Yes, please.
So we discussed that if application runs into an issue,
Yes.
so we have different strategies how to deal with it, reactive and proactive approach.
Yes.
So that can be implemented in legacy application as well. So how does Azure make it different? And what's the different experience with Azure handling this issue as compared to legacy?
The first thing is like like I mentioned what kind of responsibilities that you want to do, right? Like, yeah, you could do that in your monolithic application, let's say in your on-premises environment, but but even then, like what's your responsibility, right? So in case you are going to do that in your on-premises environment, you need to configure your complete infrastructure, and then you need to take care of your complete application pattern. You need to also take care of your security measures, your data privacy measures, and whatnot and everything. On top of it, you need to be making sure availability is always SLA timeframes for the application. But when you move to cloud, then Azure, then you can choose certain services, pick it to certain services where you will not need to do like all of those things there. Like for example, let's say you move into PaaS services, and then you will have like, okay, yeah, 70% or like 80% something depending upon the service of those features will be managed by Microsoft, and you have to manage only 30% or 20% of them. So that means that instead of you managing 100% of them, you're just handling only some of them, which is more important for you. So depending upon how you pick and choose the service, you can see like, how you can utilize your time better and then focus on delivering the application rather than focusing on establishing the infrastructure.
Basically, leveraging the services which are already existing in Azure
Yes.
rather than building to say.
Yeah.
Okay.
So you're not starting from scratch always. You're building from on top of it, right? So that's what saves it off.
Thank you.
Thank you. Let's go for a quick fix.